This video is about nuclear notation. We learned earlier that as Geiger, Marsden, and Rutherford discovered, the atom consists of a small, dense nucleus. Today we also know that the nucleus contains positively charged protons, and except for the hydrogen atom that is made up of one proton and one electron, the nucleus also has uncharged neutrons. Finally, atoms also contain negatively charged electrons that are outside the nucleus. The properties of elements depend on the number of protons, neutrons, and electrons that make up the atoms of a given element. To show the composition of elements, we often use nuclear notation as a shorthand. Let's learn about this notation. The formula for nuclear notation looks like this. Here, X is the chemical symbol of the given element, A is the nuclear number, so the total number of protons and neutrons in the nucleus of the given element, and Z is the proton number. Keep in mind that the nuclear number is sometimes called the mass number, and that the proton number is sometimes called the atomic number. Let's see a few specific examples of nuclear notation. The most common oxygen isotope that is present in the atmosphere has 8 protons and 8 neutrons. The chemical symbol for oxygen is O, and in the lower index we would show the number of protons, which is 8, while in the upper index we would show the total number of protons and neutrons, which is 8 plus 8, so 16. A radioactive element that is often used in nuclear reactors is uranium-235. 235 here represents the nuclear number. Uranium has 92 protons, so the nuclear notation for uranium-235 would be U-92-235. Finally, in this course you might also come across the nuclear notation for a proton, a neutron, and an electron. The symbol for a proton is lowercase p, and of course, as it contains one proton and no neutrons, the number in both indices is 1. The symbol for a neutron is lowercase n, and logically, here we get 0 in the lower index and 1 in the upper index. Finally, the symbol for an electron is E, and the numbers here are -1 and 0. The 0 simply shows that there are no neutrons or protons in an electron, and the -1 indicates that the charge of the electron is opposite to that of the proton. So with this, we have completed our learning about nuclear notation.